Good day to you. This is Anagalactic broadcasting to you today, Wednesday, October 19th, from Chico, California. We're currently talking about geometry, which I claim is an exceedingly important part of science. Geometry is an important part of our makeup. We do see visually, even blind people have the mechanism for interpreting visual space with the onboard system of visual perceptual space. I speak very often about people who are blind in order to underscore the fact that in science, you're not really dependent on your senses for your results. You're dependent on your senses to confirm your results. But a blind person has equal opportunity to confirm geometry. So I consider geometry to be quite transcendental in a way that numbers, I'm afraid, have proved themselves incapable of achieving. And today we have a whole generation, several generations of devoted men who are serving science through the application of numbers. This has produced technology and cannot be criticized at all for the accomplishments made on behalf of humanity. I consider the accomplishments made in technology to be 100% good. There's a footnote, but the system of linear algebra, which we now know is innate, it was blueprinted into us. So there is direct evidence of beneficence. Beyond the facts of ecological codependence, humans fit very well onto this planet. We don't really see that we were put here by mistake. Humans are not a mistake. Looked at rationally, the ecology is very well organized, and humans fit into it magnificently. Without technology, though, we would not really have gotten far compared with what we have been able to achieve in the way of a better lifespan. Just given the fact that we have a little under a century each at the most, quite a pageant, billions of human beings, each one of us is one of those. But when you add it all up, it certainly makes sense. It looks like all of this was planned out. And that's a subjective perception, perhaps. Where does science come into the picture? On the perception of design, science has made enormous strides in my lifetime in its ability to interpret the information we have from the environment to be able to prove that there is a valid perception of superintelligence, which I've taken great pains to define and bracket so that it's a useful term. It's a rational term. It's not religious, but it may be to you. That's fine. This really is part of the human goal. You may or may not be looking for something like a being, but superintelligence is certainly a giant step forward towards establishing a rational connection between any man's perception of design and reality. In other words, are you just imagining that this makes sense? No, you're not. Because of the advances made in science in my department, basically you could just think of it as relational logic. We're the structural analysts. I don't use numbers. I use structure, pure structure. database technology is not about numbers. We're always using numbers, but we also use something else that's not numbers. That's geometry. And that's why this lecture series for the past several months has been purely about geometry. I have attempted, according to my own, I guess you'd say, life path, I do include, or I have included, a lot of bracketing information on where science is at, because obviously science fits into an enormous picture of humanity, which it does have to be equated in some way, somehow, eventually. To be fully human and be fully rational, you have to face both sides. It's quite an interesting balance act, isn't it? At one moment, you're confronted with the usual emotional turmoil of life. Most of our day is spent in emotional rebalance with other humans. It's quite automatic and we take it for granted, but it certainly is nothing rational. When we go to work, when we drive on the freeway, you could say we're being rational because we're making decisions that are logical. But it's not really rational thinking that we partake in most of our life. Certainly not the first part of our life. It's almost entirely emotional, and we start out purely emotional. We respond to love and affection, and we're repelled by pain and distress. It's quite normal, but that's the emotional balance system. So I have in the past mixed a lot of the science presentation with stuff having to do with philosophy and, in my case, religion. I find myself to be able to speak to human questions that transcend science. I'm very, very aware of that, and I participate in that. However, from this point forward, which is mid-October, this is October 19th, through November and December, I intend to be focusing on the discovery that I made this year. When I began this year, January, I realized at that time that I was becoming interested in a new direction that really hadn't been part of my original course, which was in spherical rotation. I'm an expert in spherical rotation. And expert, of course, is a relative term. That might sound pompous, but believe me, I know where I stand. It's not at the top. I'm not at the top of anything in science that I know of. Although, a discovery, you do have to take that seriously. I saw this coming, and about June I started uploading these videos, which I had been making. I've been making these videos for about 2 years. But only in the last 5 months have I begun to upload them to YouTube. And that's because I hit a discovery vector. I discovered a new geometry, which looks profound. And so I've been emotionally imbalanced all summer and half of this autumn, because that's normal. That's quite natural for a human. It doesn't mean there's any danger. It just means there's emotion. And I do live alone, and I don't have any peer review. So I use these videos for several purposes, one of which is it's not just that I'm analyzing my batting swing or golf swing or tennis swing by watching myself. That is the main reason I do these, even to the present moment. I'm doing this so I can hone my technique. I've already acquired this Tonor microphone, so I don't have to wear a headset anymore. That's only been for 5 days. Or 4 days, actually. So that's a major step forward. The quality of the audio is much superior. And I've become acquainted with the methods of recording these videos. Just getting some kind of technique, because after all, this is eventually meant for the public. Perhaps not this video or the ones that I've uploaded so far. Those I am willing to share with the public if anyone wants to see them, but I'm not advertising, and I'm certainly not looking for money. That makes me an outlier in the YouTube ecosystem. I'm not unwelcome, but I haven't really done anything. That's obviously causing me some increasing emotional instability. And this is due to the nature of the pressure of the scientific imperative to communicate. Unfortunately, as we all are aware, and perhaps don't need to be reminded, but it's on my mind all the time, is that for every one amateur scientist or, unrecognized scientist who thinks that they have something to contribute, certainly I'm not alone in that's going on all the time in science, and quite frankly, most of the attempts, even from within science, are not likely to succeed simply because the odds of making progress in science are really dependent on you being able to reach the cutting edge. And that takes time and training for what we would consider to be an ordinary sequence of discovery. In other words, it's unlikely that a layman thinking that they have a contribution to make, it's unlikely that it's going to be real. It's much more likely that they simply need some peer review or some way to, fix whatever, because you're not going to get a discovery correct without following proper procedure and without realizing it. I think a lot of people assume that when they understand something and perhaps pursue it, they get the impression that they can see better, or there's a controversy going on and they want to add their voice one way or the other because they think they have a valid opinion. Well, then they think they need to be heard. But this is a much larger demographic than a discovery scientist trying to be heard. Let's say that there were a forum, say like YouTube, but something geared towards just discovery science, something like a clearinghouse. There have been attempts lately to set up just such a thing. I'm actually enrolled and used to participate in quite a high level forum, which is interactive online, where you get to just type in things, and is quite sophisticated, where I've been able to actually contact and communicate with some of the men whose names I only know of through books and lectures. In other words, men that I follow and admire for their research. I get a chance to communicate with them. The name of the forum I could tell you, but it's not necessary for me to do so. I'll just give you an idea of what it is. It's a forum basically for geometric algebra research. And of course, I'm extremely fascinated with geometric algebra. And I could post in one of those forums because they're organized so that I could actually get down to a relatively safe, because you don't want to be presenting a discovery unless you want it to be taken seriously, in which case it's going to be massively criticized. The job of science is not to usher everyone forward who has an idea. It's not really benevolent in that way, because you have to stop and think about the logistics. Somebody has to review your work, and those men are busy. The ones who could probably help you, now speaking of myself, I wanted to simply present this geometry, which is actually quite simple but has enormous ramifications. A new number system and a new geometry, if that were in any way real, would attract attention from a certain area. Just to check it out, maybe just get a blurb and see if it's something worth looking at. but it's a commitment on the part of people who are busy. I'm really not of that league. And so I'm really trying to put my foot in the door. And I'm not really that kind of person. I've never really sought anything like this. I'm, I'm really resigned. It's not a matter of desperation, but just practicality. I'm more or less a recluse. My wife died 14 years ago. And since then, I just live alone. I don't have any pets. I have a plant. But I'm happy. I'm perfectly stable. But in science, and I did not seek this. I didn't know I was going to make a discovery. It's only been in 2022. I've been doing science continuously for 14 years. But I'm not a mainstream scientist. I was in the database side of the computer industry, so I do have roots in the science system. But it's quite remote. I was a database programmer. That's a rational logician, basically. We don't use numbers. We're not really programming circuitry. We're making structures. And this, I have a gift for this, relatively. It's a strength. I'll call it a strength. So I'm vastly attracted to geometry. I couldn't make progress in school beyond the necessary mathematics because I really have a problem with mathematics. Not with the conceptualization. I have no problem with algebra. I don't even have any problem with calculus anymore. I really don't have any problem with anything in mathematical physics. I did have to study on my own, but I can read and understand what men say at the very top. I understand what Max Planck has done. I understand what the quantum mechanists have done. In other words, I understand their formulas and their geometry very well. To a certain threshold, I'm not what you'd call a physicist at all. But I am vastly interested in everything that science wants. It just has come my way. I was a Bible scholar, but I'm not at all that anymore. I'm pursuing a rational, logical course of analyzing science for its discoveries with a concentration on spherical rotation. I've always been concentrating on that. Well, that was my ticket into the hidden inner world of the cutting edge of physics, the cutting edge of mathematics, and the cutting edge now of geometry. I've made an extensive, prolonged study of geometry, mostly lately in an attempt to discover any leads that may have already been noticed in the direction that I've been led, which is very easily stated. The line has a number system which we've used exclusively for 2,000 years and never had another geometry. There are types of linear geometry, but they're all linear geometry, all of them, based on Greek. We have no spherical geometry. Is there such a thing? Well, we say there is, and then we construct it with lines. So we do have a spherical trigonometry that requires transcendental functions and calculus, sine and cosine, the whole works. The stuff that just seems like it's baggage. Calculus is a very unwelcome development. It's a complication that's necessary for machining numbers. And we can machine numbers on Earth to shave off the irrational part, which always has to do with curvature. But as the Pythagoreans discovered, even linear numbers have irrationality on plane figures. This was first noticed, I'll say, representatively. Obviously, irrational numbers are normal with linear algebra. We're constantly using irrational numbers. That's strange, though, and that requires some explanation. How are we able to use irrational numbers? Irrational numbers, by definition, are numbers that are not precise. Whereas in geometry, everything is precise. Now, that's not quite true. it turns out that linear algebra does not only have a problem with curved lines, which necessitates calculus. Calculus gave us curvature, rational. We can machine the irrational results found in curved lines and shave off two numbers. From a circle, we can get two numbers. From a sphere, we can get three numbers with 3D Euclidean algebra. And these three numbers describe cubic space. All of this is well known, well accepted, and it's worked miraculously on Earth. The only question that just came my way is, what is the relationship, for instance, of the number system to the object? And it turns out that in my lifetime, two major breakthroughs have been made, which solidify and finally define what is the number and what is the line. And it turns out they're the same thing. It's an object. The line is an object that has a number system that all you have to do is locate it. And we did locate it. It took a while. At first, all we used were counting numbers, that is, positive whole integers, beginning at 1. You can find this in the history books of mathematics and algebra and geometry, that at first counting numbers were the only numbers, and it really wasn't on a line. There was no such thing as the line until the Greeks used the line. The numbers were already known, but they were counting numbers. And then the Greeks discovered a relationship between numbers and lines. And it has since been shown 2,000 years later that the reason that the line and numbers work so well together is that lines represent distance. And by the way, that's all a line represents, is distance. That's all it can represent. It's a spatial, purely spatial object. And the significance of that, as we've found out from my line of inquiry, my line of research, the number in relationship to the line is unique. There is no other object that we've ever used that has a number system. The line simply does. And we found the zero eventually. It's attributed to the people of India, the scholars of India, quite a while ago, centuries ago, discovered the zero. But it still took a while, and it is remarkable to me that the line had never been fully understood, even by the Greeks. That it really is necessary to really analyze the number system of the line. And here it becomes interesting looking at how we were trained in mathematics in grade school. Our initial instruction in geometry and what is called algebra. Algebra is nothing but mathematics with the use of symbols, placeholders. Otherwise, it's just mathematics. And what is mathematics? The way we're taught is 4 operators. To make a long story short, what I've discovered is that's incorrect. The line only has 1 operator with its inverse, its add and subtract. And those are the only 2 operators for the line. But that's not what we're taught. We're immediately taught multiplication and division. And then all hell breaks loose. Now it's no longer Euclidean. Now it's no longer logical. Now it no longer works. It's not a closed system when you add multiplication as if it belonged to the line. It does not. Multiplication and division have nothing to do with the line. You can't do multiplication and division without leaving the line. Add and subtract take place only on the line, and it's a closed system for add and subtract. If you add 0, we take this for granted because 1 and -1 are not separated by a distance of 1. 1 and negative 1 are separated by a distance of 2. And that's called its magnitude. The magnitude of the line's segment is 2. If it's the distance from negative 1 to 1. And the reason why that is 2, we take it for granted, but bear with me. The reason why the distance from negative unit to positive unit, these are the counting numbers in 2 directions, they cross the middle. The 1 goes down to 0 and then backwards again to 1. So there has to be a 0 point, and that 0 point is the death of the system. Not for add. Not at all for add and subtract. The system is closed and it works for addition. And that is miraculous. That single fact is that the line, given the Archimedean balance point of 0, which is a number now, 0 is then a number in linear space, that number has an evil property. That number is not quite a real number. And the reason why I'm allowed to say that with absolute confirmation from rational logic on what I said, what is the proof and justification for my grim assessment of the linear algebra system? It's that when you add multiplication and division, which is an illegitimate thing to do, you're stuck with 0 not working for that because of division by 0. Division by 0 simply cannot be defined. And our computers prove it. With physical circuitry, our CPUs, all of them, have to deal with division by 0. Because if you study the architecture of the strategy for composing a CPU computer system, the central processing unit is the binary part that actually processes the 1s and 0s. And you know it's all 1s and 0s that are pushed through the CPU for interpretation. And there's a division operator that's programmed into the CPU, which will do everything that you would expect it to do unless you give it a denominator of 0. And if you do that on a simple CPU that otherwise is perfect, and you run a division by 0, it's just a block of code, a piece of code, that when it gets to putting in the denominator for the division operator that you're summoning, it fetches that number from its storage location, only it's a 0. And that 0 goes into the denominator, and then you push that through. On that step, the CPU will freeze, and you'll have to restart. You'll have to unplug it to restart it. That's called a division by 0 error, and I spent a long time over my career studying the division by 0 error. It's absolutely terrifying, very much downplayed by modern industrial science, which, knowing that the CPUs are rigged now to catch the division by 0 error, CPUs can catch it at that level, and then they issue an error, but it cannot process a 0 denominator. It can't. And so you have to catch it. That slows down your whole system because now you have to check every single operation. Then you can program it, only check on a division request. And then check for 0. But then for every division, you have to check for 0. Well, you don't want to have to do that. Well, you have to. Because there's a hole in linear geometry. Now, another thing you can do at the programming level is fence your own code so that you don't send a division by, you catch it. Well, that's going to slow down your code. which means you're not going to be able to compete in the market in the speed division. So all computer programmers at the production level are always trying to cut the speed. They want it to go as fast as possible. And so you don't want to have to check for division by zero at all. Well, you have to. Somebody does. At all times, that division by zero has to be monitored. That's because it's a singularity. That is the correct definition of a singularity. And this is massively ironic, as the British would put it. Because you may have heard of the singularity in context of the black hole and the singularity in the context of the Big Bang. And I'm going to translate those two terms, supermassive black hole and Big Bang. Those have been changed. Those terms are obsolete now because they're disgraceful terms to science. Big Bang is a children's playground term that does not belong in science, and I'm forced to take a hard line on this. It's my job. So the Big Bang is the BB, and that's what it's going to be known as from now on. I'm not going to comment on that anymore, and nor am I going to comment on the fact that I will not be referring to the supermassive black hole. By design, I'm going to avoid that term because it's miraculously evil. It's a stupid-ass word. It has to be changed, and nobody's had the nuts, the balls, the bravery, the manhood, the courage to change it. Because science can't do that anymore. It's not self-corrective. Well, I know how to correct it. I simply change it. So the supermassive black hole, a very badly formed pseudoscientific name, now has a genuine scientific name. It's called the Panther. The black cat, the panther, that's my Halloween present to you. You don't have to call that black hole, really. And that's supposed to elicit respect for scientists who call one of the most important objects ever discovered in the history of mankind, they call it, wait for it, a supermassive black hole. That makes no sense. It's misleading. And I have a right to critique this. It is my job, and also I've discovered the fix for why they call it a black hole to begin with. It's because they can't figure out what it is. It's just that simple. They don't know what it is, and I'm going to tell you in a nutshell, in context here, as we gear up for this lecture series today, that the Panther, which is a galaxy-scaled object, the Panther does not have a singularity because there's no such thing as a singularity. Linear zero does not exist. It's not a real number. So that's extremely important to understand, that zero is not a real number. It's really an imaginary number. What it represents on the line, which is its only valid meaning. Zero has an extraordinarily valid meaning. It's not that it doesn't exist. It does exist on the line, but you have to know what it is. It's a number on the line called zero. Well, what does that represent? Well, we've learned, and I'll just tell you this because I don't think anybody else ever says it like this. The line only does one thing for us. It measures distance in space. That's it. Linear distance in space, nothing else. Linear distance in space. So what is zero then? It's zero distance. It's zero distance. That only has meaning in context of the line. And why am I emphasizing that? Because if you still are using your number system with its zero in it, which we do, obviously, it's all we use. We've never taken care of the zero. We don't know why it fails. It just does. And so the zero is an enormous problem in computation. It's an enormous problem in physical mathematics. The zero is a nightmare. And it needed to be analyzed and fixed. Somebody needed to fix the number system. Well, nobody for 2,000 years has even tried to do that. Nobody's ever attempted to fix the number system. And the most obvious reason that might jump to mind is maybe there is no number system other than the linear numbers. Well, that's illogical. You have no reason to think that. You didn't even know there was a number system until the Greeks put you onto the line. Speaking for all of us. So now we know that the line and the number system are isometric. They're exactly the same thing. The line is the number system. Well, that means it can't do anything with curved lines. It can't measure curved distance. It can't. It only measures straight distance. Well, that's an extraordinary limitation now because the universe doesn't use that method. The universe does not use linear anything. Nothing in the universe is linear. Although you could say that it kind of is, and that turns out to be good enough. Our linear numbers are capable of reaching. What is it? What is it we're trying to reach with our linear numbers? Cosmic space. We're trying to compute and understand the cosmoses, and the whole thing called the universe I prefer to call the cosmos, because it's the sum total of the physical universe would be the largest unit of matter. Well, that's the cosmos. And you know, when you say universe, you're like extending that to everything there is. That doesn't make any sense. You no longer know what you're saying then. So universe is I don't like that term for that reason. It tends to give the wrong impression of everything there is, which is a nonsensical statement. So we are trying to understand cosmic space. Does that differ at all from linear space? Well, so far the answer that's been assumed at upper echelon physics is no, linear numbers are working just fine in cosmic space. Are they? I found several direct flaws in the application of linear algebra to cosmic space. And the premier proof that I am right in critiquing the number system itself, that's the culprit, is that zero and the linear number system, which is restricted to linear space. It can only compute linear space. Well, then you're going to have to make the universe out of cubes. And that's 3D Euclidean space, which is still what is used. Einstein did not change that. You know what Einstein did? He took the faulty 3D system, which now has 3 singularities in it. 3 zeros are in that system. When you have 3 lines to make space, you have 3 singularities. That's unbelievably complicated. Unbelievably complicated trying to step around those 3 landmines. 3 zeros that you have to avoid. Well, you know what the Princeton scholars have done after the discovery of what is assumed to be a panther, a galactic scale bobcat, a formerly called black hole, stupid name, is now called a bobcat. And we're not sure how small the bobcats can get. The first bobcat ever discovered was Cygnus X, I believe it's called, which is a code name because they didn't know what it was. It was a binary star, but you couldn't see the companion. Well, that has since been measured through the gravitational relationship between two binary stars can be studied as they orbit around each other. And from that you can get the gravitational correspondence between the two bodies, only one of which can be seen. And that's where the word black comes from. Black is a placeholder for when you're finally ready to engage your brain and give it a scientific name. You call it black because you're in the dark about what it is. So it's probably good that they do call it a black hole, because it shows their ignorance. And they are quite ignorant of what they're looking at. It can only be interpreted gravitationally. The bobcats and the panthers are gravitationally understood. And so it was determined from Cygnus, the Cygnus companion, that it was a compact black object. And compact and black, they wanted to know its density. That is, its mass. The mass of the companion that cannot be seen. That was computed to a very large amount of gravity, which suggested to the physicists that this was the result of a collapse of nucleonic structure. That what we conceive of as the atom was pressurized. It due to the result of a mass of basically protons and neutrons, because those are the only things that have mass, are protons and neutrons. Those are called nucleonic objects. They're particles. And the proton and the neutron are almost the same thing. But on a quark harmonic, they can switch to each other. So the only difference is the proton has a charge, whereas the neutron does not. But apparently, and this has been confirmed to a high degree of accuracy, the proton-neutron thing, which I call simply a proton, bends space. You can think of it that way, but it's better just to think of it as gravity, which is simply bending space. We notice that because we can all stand on the surface of the earth and none of us fall over, even though we're standing on a spherical surface basically all around the globe. Our feet are basically pointing at each other. So we're standing on a spherical surface being held to the surface by an internal contractive force. And so we're all being pulled to a center. Now that center is not a zero. It seems obvious that you shouldn't call the center of a sphere a zero. But you see, we have no choice but to call the center of a sphere zero if we're using linear distance measure. Then you have to have a zero, because you can only measure on a straight line from zero. Correct? It's the center of the spherical system would be a zero. That makes the singularity. The singularity that is now called a physical object is a singularity. That's incorrect. That singularity is purely in the Princeton mathematicians' minds. What is of monumental importance that they have not yet perceived is that their formulation, using zero at the center of the black hole or zero at the beginning of the universe, is incorrect. It simply is incorrect. There is no singularity there, and the universe did not begin with a singularity, and no black hole has a singularity in it. Well, I just contradicted everything discovered in astrophysics about the black hole and the Big Bang. And that invalidates everything that they have said about the Big Bang and about the black hole. They don't understand it. I do. And I've proved it with a massive sequence of discoveries as a result of the correct number system. Because once you have the correct number system, you have the right geometry. And that's where we begin the lecture series today at 45 minutes exactly. I'll be back after stocking up on some water. I have a very fair day in Chico here, and you can tell I'm modulating my voice a lot better now. I have a good microphone. I'm stepping up my game. Not too many more stories. Not too many more excursions into philosophy and religion and the human side of things. No more discourses or rants about the condition of science in this world. No more criticism, no more emotion. We're now going to get all the answers that science wants. I've already outlined the discoveries I've made. Absolutely incredible series of advancements in astrophysics and in pure mathematics. The absolute beginning of a cultural revolution. This will transform the world if it ever gets peer review and I end up being right. I cannot say I'm right until I get peer review, because science has to be consensual. It can't be me alone, or it's just for me. That's not science. So I have to do this. I have to expose what I've discovered in the most cogent, presentable manner I can. I intend to do that throughout the remainder of this month of October, my birthday month, and November and December, and by Christmas, we should have everything, including what I've been promising, because it's my goal now, is to get the absolute definition of time for the first time in history. That is now within reach only with my geometry. And let me just explain to you very quickly and easily why only my geometry can work. It's because Albert Einstein has proved that you can no longer talk about space by itself, nor can you talk about time by itself. You're going to have to put them together. Well, everyone's tried to put it together the same way Albert Einstein did, which was by making a fourth stick and twisting them into hyperbolic space. And I'm afraid that that is not going to be correct. The fact that it works analytically is meaningless here. It's that Einstein led us into a dead-end alley that's filled with garbage. And that's exactly what happened. After Einstein made his discovery of the best definition of gravity, and therefore our first extension of our mathematics in the cosmic space, our first attempt to get cosmic geometry was general relativity, the Einstein field equation. You know what happened in quantum mechanics at the other end? We're going to be covering that too. I've already solved the quantum paradox. One of the most amazing statements it's possible to make. Unfortunately, it sounds a little extreme, because why would I have gotten this when none of the other scientists did? Very simply speaking, you need to use the numbers that Einstein prescribed. He's like a doctor, and he made the best prescription that he could. He gave us the answer for gravity so we could have GPS and understand that now time and space are not separate. That's called time-space, but it's a 3-1 signature, and that doesn't work. It's linear is why it doesn't work. It's why it's 4-tensor calculus in hyperbolic space, strictly due to the fact that Einstein was forced to use sticks. I have discovered what Einstein would have given his Nobel Prize for, although he did give it to his wife as he promised he would. He's a good man. I really like Albert Einstein. I think you can tell he's one of my heroes. And it's an honor to follow in his footsteps and correct his mistake. That's quite pretentious sounding. This is serious, very serious. I take it so. He showed us that we need a two-component number. We must invent a two-component number. Well, complex numbers don't work. And also, Einstein's formulation does not work for the same reason the complex numbers don't work. You have an imaginary number. I hope you realize that in the Einstein field equation and its geometric formulation, time is imaginary. It's imaginary time. We don't want imaginary time. We want actual time, don't we? That can be had, but only when you evolve. You're going to have to evolve. There's no other word for it. We're going to change our number system to the right one, the correct one, for cosmic space. There's only one geometry for cosmic space. That's what we haven't learned yet. And it's not the geometry we use. We're using lines. Well, we can't now. I've discovered a two-component number formation that defines a new geometric space called spherical space. I checked and checked and checked. If I missed anyone having discovered this, then it's my fault for having overlooked it. But I don't feel much of a twinge, because if anyone has already discovered spherical geometry, they haven't published it. No one in history has thought of this. To make a new number system to describe the sphere. I discovered that. That's going to change everything. We'll be back. That's 51 minutes. We'll have fluids. I'm keeping my tone down. We're going to stay serious here because I've tried to make you understand in this lecture. This is the most serious thing that science has faced in 100 years. It's the gateway to enlightenment. I believe it's nothing short of that. I've already told you about my expectations, which have to do with my emotional situation right now. I'm basically paranoid. I go through it every day, feeling like I haven't presented this yet. I've only begun. I'm warming up to present this somehow. I have no idea how I'm going to do this. But I have some ideas now because I've been thinking about it so long. But you see, I'm expecting to be shot down hard. And I don't like doing this. So I've tried to make myself more of a military mind, like I'm getting my enemies, the necks of my enemies. It's just psychology. I'm trying to gear up for what I don't want to do. I don't want to have to persuade people of something that they simply don't want to hear. I've learned in the churches not to do that. You don't want to be pressuring scientists to do something that they don't want to do. They don't have to, okay? They're being paid. They're fine. They don't need me. Well, I've said that I don't need them either, but we're both lying. We all need each other. But if I'm a nuisance, a troll, I'm just another annoyance, just weighing them down with a weight of trolls and just people who need attention, and I'm just another one of those. I don't want that. I don't need that in my life. I'm fine. I don't need to do this. But I've taken a vow, okay? It's really... And there goes my voice, so we're going to cut this off now. No more rants. No more beer either. No more human side. We're going Vulcan now. This is it. All the way to Christmas, this is going to be geometry. I really hope you enjoy this. I hope I get some followers eventually. I'm not advertising for them. But someday, somehow, if I get my act together and do something to make this be heard, these'll have been done, and I'll still be increasing my knowledge and my understanding. I'm not going to stop. I'll never stop. This is what I'm going to be doing for the foreseeable and unforeseeable future. Yes, I'm still human. Yes, I participate in the human race. That's quite unavoidable, and I'm glad of it. It's a game. I look at life as a game now. It's not always possible to have a gamesman, happy-go-lucky. It's how you play the game. It's not whether you win or lose. It's how you play the game. Well, science is pretty much convinced now it's whether you win or lose, which is money. It's whether you win or lose. Money. Whether you win or lose. Money. Not how you play the game. Wisdom. Not how you play the game. Understanding. Not how you play the game. It's whether you win or lose. Money. Not how you play the game of science, which should be for wisdom, which begins with understanding, which begins with knowledge. We found heaven. Just within the past century, we penetrated the veil of heaven. We have a ton of knowledge. We have all the knowledge we need to figure it out. I'm just telling you that straight up. We've reached the edge successfully, although it requires my interpretation to get it right. We've also reached the middle. That is the center. The subatomic particles, that's what we're talking about. Yeah, quantum mechanics. It's not mechanics. I discovered that. It's harmonics. The same thing with the linear system hole in it prevents quantum mechanics from being penetrated. It does take an evolutionary leap in your mind to actually get this. But you can't do it without geometry. It has to be rational. You can't just make up the answer to the quantum paradox. And it's going to stay a paradox because I'll tell you what it's going to come down to. The final location of the paradox is going to be our human limitation. That physiologically, we can't see what Einstein showed us. It's a physiological limitation, and so we have to use what's called averted vision or perspectual vision. You have to do something to get another aspect on what you're seeing. That's another way of saying you need a two-component number. But it has to be perfectly rational. According to the way we understand how linear numbers work, that cannot be abrogated. The linear number system is here to stay, with its hole in it. But can it be integrated? Can it be integrated so it does not any longer have a hole in it? And then the question would be, are these computable numbers? Would the two-component numbers be computable? They have to be computable. These are the things that I've already proved are the entire multiplicative system of spherical space is closed and rational, just as it was for the line for add. The line is closed for add. The sphere is closed for multiplication. I discovered that. And so it is a new number system, which instead of filling a space with numbers, which is the line, that is a linear space, one-dimensional space, filled with numbers. But they're on a line. What if you could get the numbers into spherical space? Then you could compose the entire universe. You'd get all of space in one shot on a sphere. We never noticed that that can be done with reciprocal numbers. And that way, the fractions that are less than 1 go in to compose all the numbers inside the sphere, which is now the number 1. That takes the place of 0. The equivalent of 0 in multiplicative space is the multiplicative identity. Just as the additive identity is 0 on the line, the multiplicative identity is 1. But that makes a sphere which encloses space in two directions. It encloses all of space going out, because that's where that is. It's what's not in. But the in is right there where you can see it. And that is in, and the rest is out. And that's the axis of the universe. It's not a linear axis, though. It's a radial axis with two components. And the radial axis, all the lines going out at once, that radial axis has a perpendicular component called the sphere. If you see all those lines going out and you draw a perpendicular to all the lines at once, it makes a sphere. So it's a closed geometric object, just as the line is for add. but the line is not closed for multiplication. It has a hole in it, and I found out the reason for that. The linear numbers are derived by the calculus. This geometric calculus. My apologies to David Hestenes, who wrote a book called Geometric Calculus, and now geometric calculus is a major topic in time-space analysis. Geometric calculus is a major contribution by David Hestenes. In the universal language of physics, he's captured calculus itself, quite an accomplishment. It's useless. It's useless for cosmic science because it's calculus. I discovered the solution which fixes David Hestenes's insight. He didn't see this either. He's an expert in linear algebra. One of the best of all time. He unified the language of linear algebra. That is an amazing accomplishment. I consider that to be in the top 10 accomplishments of humanity of all time, was finding the universal language of linear algebra. It's called geometric algebra. Purely 100% linear. No way to get rid of that zero. Nobody's ever attacked that zero to get rid of it. I did. It's been transferred to the next highest integration. The multiplication system is the integral system of additive space. That can be proved. And therefore, the irrationality of the line disappears. You get rid of all the irrational numbers on the line when you integrate them to spherical space. There are no more irrational numbers. Well, and no more zero. No more division by zero. No negative numbers. These are all positive. The valence that we associate with plus and minus has to do with linearity, but the valence in spherical space is in-out. Those are the two infinities that replace the linear two infinities. The two real infinities are related. The center of the sphere is not zero. It's 1 over infinity. And infinity is infinity over 1. What happens when you multiply those together? You get 1. What happens to the infinity? It goes back to being imaginary space. And therefore, the universe is surrounded with imaginary space. You could think of it that way. And therefore, the universe is finite, because it's bounded by what does not exist. That's a remarkable avenue towards solving some ancient paradoxes. This geometry does that. What I've noticed is in using this geometry, just understanding it and following what I show you, how to use it, and things just jump out at you. It's just right from the start. This is suitable to teach to grade schoolers. A simple geometry of the sphere based on multiplication, extremely simple. I could teach a 4th grade audience. Within a half an hour, I'd have them understanding spherical space. It's not difficult. The fractions all live inside the sphere, and the whole counting numbers all live outside the sphere. It's really that simple. It sounds like, well, how could that be useful? It's like it's self-evident, but what good is it? Well, it fills all of space with numbers. The line can't do that. So now all you have to do is know how to manipulate the numbers, correct? Well, the beginning is to see where the numbers live and how they relate. The sphere is 1, so there's a number. And you know what the first counting number is? This is equivalent to 1, which is the index of the space on the metric. We invent the number 1 because it's the first counting number after 0. And now you have your unit of distance. It's only distance. We've never been able to measure anything except linear distance. That's why we think of time as linear. It's convenient. Albert Einstein showed, but you're wrong. It's not linear. That's an illusion. That's very, very hard to accept for a linear algebra person, is that our instinctive concept of linear distance in space and the innate linearity of time are both illusions. And neither one of them is correct in the strictest sense. There is no correct measurement of cosmic space using a line. You have to use spheres. And that's what Max Planck proved. Is spherical space is now the only space that's going to have rationality in it for heaven. Does it retroactively apply to what we've done on Earth with calculus and linear numbers? Absolutely it does. All the constructs that we've got out of calculus are communication. They're laws. If you have a blueprint for building a turbojet engine, that is extraordinarily valuable information. You don't want to lose that blueprint, because if everybody dies who knows how to make a turbojet engine, well, then you're not going to get any more turbojet engines. Someone's going to have to drag out that blueprint, understand it, and redo it step by step. And if the algorithm is correct, you got your turbojet engine back. So all of that is extraordinarily valuable. But now you can actually integrate any of the solutions that were derived by calculus and translate it back into integral space to see what it is geometrically. It's a tool. It's a tool that might work on Earth. I honestly don't see any serious applications on Earth, but definitely not to be ruled out. This is valid geometry, and it's the same geometry we've been using, just integrated. Well, integrated means you add back some information that you had lost. On a derivative, you always drop some information. That's why calculus cannot work for universal space, because it's cubic and you have to shave off the edges. Well, in the universe, you can't, and therefore your number system won't work, period. It won't work. It doesn't work. And that's why they're making so many mistakes in cosmic science. The Big Bang is completely misformulated, and that's why the plasma physicists are off their rockers. And you'll never understand what they're doing. They don't understand it, but they're being funded. There's a reason for that, but it's covert. I don't want to go into that. But you don't want to worry about what the plasma Big Bang people are doing. They're not doing anything for you. They're doing what they're doing for the government. And if you want to know why they're doing what they're doing, you would have to know why the government wants them to do it. And that's going to get you over your head. I'm just telling you, we're not going there. But I am telling you that the Big Bang maniacs are excited and out of their minds because they're being paid to be excited, okay? That doesn't mean they have understanding. They can't possibly have understanding without this geometry. The geometry of the sphere, that's 1 hour, coming up on 1 hour and 10 minutes. That's enough. Now you know what I'm doing. I'm just a country doctor, just like Bones. Jim, I'm a doctor, not a bricklayer. You're a healer. There's a patient. This is the Horta, which is a rock creature. He said, I'm not a bricklayer. Has to heal this rock creature of a wound, right? It's got suppurating silicon. The doc has to do something. So he got some ferroconcrete glue from Scotty and just plastered, and then the Horta lived and fell in love with Spock, and it's a wonderful Star Trek adventure. And so's mine. I feel like I'm on a Star Trek adventure. But we're not going there. We just want the facts, ma'am, just the facts. Intergalactic, we'll be back.